Okay, so section 2.2, constant rule. That's our first thing. So if I have something like, f of x is just a constant, 3. F of x equals 3. G of x equals pi. Why not? Great constant. And so forth. On and on and on. H of x equals negative 2.7. Something like that. Then in all these cases, f prime of x is equal to 0. G prime of x is equal to 0. H prime of x is equal to 0. A constant, when you take its derivative, if that's all you're doing is taking the derivative of a constant, you always get 0. And we can see a picture of that. Why? Well, here's f of x. There's 3. There's x. There's y. There's f of x. It's a straight line, so its tangent line is itself. And what's the slope of that tangent line, or what's the slope of that line? 0. So, constant, you should get 0. And now, here's the theoretical mathematics. So suppose I have f of x is equal to some constant k. Now, let's find f prime of x. That is defined as the limit as h goes to 0 of f of x plus h minus f at x divided by h. But now, evaluating those, we have the limit as h goes to 0. Now, f of x plus h, well, f of whatever, it doesn't matter what I put in there, it's k. It's a constant. Minus f of x, that's k, divided by h, and look at that. And so we get 0. Okay, now you may think, okay, I've got 0 over h. If I did direct substitution, I'd get 0 over 0. I didn't do direct substitution. I said I had 0 over h, and for every value of h that's not 0, and remember this is a limit, I don't care 0, what's happening as I'm approaching 0, for every constant h that's not 0, I get 0. So the limit is 0. And there you go, there's our proof. And so there's our constant rule. I want the derivative of a constant, pi is a constant, e is a constant, I get 0. And so there we go, first rule.